Hello, I welcome you all to this channel again. In this video, we shall see solutions for all the previous appeared EPR NET questions on EPR spectroscopy.
First question, it is very simple. So what they are asking here is that the number of lines exhibited in high resolution EPR spectrum of copper ethylene diamine species. Copper ethylene diamine twice this species. So as I have shown the structure here, of course copper 2 plus complex, it will be having just one unpaired electron, and that one unpaired electron it will couple with copper first, and then if any other coupling is possible, even that coupling is to be considered. So number of hyperfine lines, we can just first consider the coupling with copper, and again 2Ni plus 1 formula. 1 copper is coupling, and copper I value it will be 3 by 2, and plus 1, if I do this it will simplify to 4, and then again 4 nitrogens are there. It is diamine complex, ethylene diamine complex, so therefore because it is bis ethylene diamine, 4 nitrogens are there. All those 4 nitrogens, they are identical and they will also couple. So therefore now I should consider that 2 into 4 nitrogens are involved in coupling. I value of nitrogen it will be 1, so therefore 2 into 4 into 1 plus 1. So this, if I simplify, it will come to 9. So 4 into 9, totally 36 lines they are expected in this spectrum. And we have one of the option as this 36, and that can be considered to be the correct answer for this question. Right. So the second question, it is the number of lines in the ESR spectrum of CD3, the deuterated methyl radical they have given. In the case of deuterated methyl radical, how many lines do you expect in the hyperfine split or hyperfine structure of the EPR spectrum? That is the question. So again, very simple, one unpaired electron it is there, and that has to couple with 3 deuterium atoms. And for deuterium value, deuterium I value, they have given that I is equal to 1. Again, straight away this formula itself, 2Ni plus 1 formula. So in place of N, it is 3 deuterium atoms which are involved in coupling, that is to be considered. And I value of deuterium, it is given, even if you do not know, it is given to you as 1. So if you just simplify that, you will get that 7 as the answer. And what we can expect is 7 line spectrum we can expect in the case of CD3 radical. So just for your information, I have included the if it is 1 deuterium which is causing splitting, how the signal it would split, and if it is 2, how it would split, if it is 3, how it would split, that has been included here. So 1 deuterium case hinde helideni, 1:1:1, right? So this is non-Pascalian behavior. So ಇದನ್ನ ಹೇಗೆ ಬರಿತೇವೆ ಅಂದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾವು 2 ಡ್ಯೂಟೀರಿಯಂ ಇದ್ದಾಗ ಫಾರ್ 1 ಡ್ಯೂಟೀರಿಯಂ 1:1:1 ಬರ್ಕೊಂಡಿದ್ದೇವೆ. Pascalian distribution ಬರಿಬೇಕಾದ್ರೆ, so intensity in the next line we write it in between 2 letters or in between 2 intensities. So illi ಬರಿತಿದ್ವಿ, ಮಧ್ಯ ಬರಿತಿದ್ವಿ. But in this non-Pascalian distribution, or say when I value that is equal to 1, in that case whenever you want to calculate the intensity ratio, so what you can just remember is that so the next line, in the next line you should write exactly below the first intensity, right? So again end dali yavagalu adu, whether it is Pascalian or non-Pascalian doesn't matter, it will be in the end always 1. So that one I have written. So what I should write here is that ಇಲ್ಲಿ ಏನು ಬರಿಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ಇಲ್ಲಿ ಇದ್ರದ್ದು ಮೇಲಿನ ಲೈನ್ ಅಲ್ಲಿ 3 ಏನಿರುತ್ತಲ್ಲ ಅದರದ್ದು ಸಮ್ ಇಲ್ಲಿ ಬರೆದ್ರೆ ಆಯ್ತು. ಸೊ ಹಿಯರ್ ಏನು ಇಲ್ಲ ಅಂದ್ರೆ you can just assume that it is 0. So therefore here what I should write is, it is sum of these 3. So that is 0 plus 1 plus 1 is 2, right? So here idradu ಕೆಳಗೆ ಏನು ಬರಿಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, sum of these 3, that is 1 plus 1 plus 1, that is 3. So here again same thing, ಇಲ್ಲಿ ನಾನು ಇದ್ರದ್ದು ಕೆಳಗೆ ಈ 1 ಕೆಳಗೆ ಏನು ಬರಿಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ sum of these 3. Here nothing is there, so that means it is 0. Therefore it will be 1 plus 1 2, and ending always it has to be 1. So this is for 2 deuterium. Similarly I can continue for 3 deuterium, right? So I can just start with 1. So then what I should write here is, it will be like 0 plus 1 plus 2, that will be 3. So what I have to write here is, it will be 1 plus 2 plus 3, that will be 6. So either ಕೆಳಗೆ ಬರಿಬೇಕಾದ್ದು 2 plus 3 plus 2, that is 7. And again here it will be 3 plus 2 plus 1, which is 6. And again here ಇದರದ ಕೆಳಗೆ 2 plus 1 plus 0, that is 3. And lastly 1. In that way you can just continue. When for 4 deuterium ಎಲ್ಲಾದರೂ ನಿಮಗೆ coupling ಬಂತು ಅಂತ ಹೇಳಿದ್ರೆ, in such case also you can expect this kind of intensity ratio, right? So ಕೇಳಬಹುದು, there are chances that once they have asked about just the number of hyperfine lines, but even one step ಅದಕ್ಕಿಂತ ಮುಂದೆ ಹೋಗ್ತೇವೆ ಅಂತ ಹೇಳಿದ್ರೆ, it is possible that they can ask you the intensity pattern for those 7 lines. What exactly is the intensity pattern? So that intensity pattern, it will be this. The next question, again it is very straight away question. Straight away they have asked the EPR transition selection rules. EPR selection rules ideyaru delta ms spin change, it should be plus or minus 1, and whenever hyperfine splitting is involved due to the interaction with the nuclear spin, mi value 0. Idu gottide anta helidre straight away we can mark that option B, ms is equal to plus or minus 1 and mi is equal to 0, that as the answer. Just for your reference I have included this diagram. Say ನೀವು ಯಾವುದೋ ಒಂದು ಸಿಂಪಲ್ ಕೇಸ್ ತಗೊಳ್ತೀರಿ, like say ms is equal to minus half and ms is equal to plus half, two energy levels, and both these energy levels, let's assume that further they will split with the interaction of a nuclear spin. This level it will split into two more levels, plus half and minus half level. This plus half and minus half will correspond to mi values, right? And similarly this energy level it will split into two energy levels because of the interaction with the nuclear spin. And now you can expect transitions. Two transitions are expected. Those two transitions which are expected, they will follow these rules. So the thing is that already it has been explained. So basically illinda illige transition barbeku from here to here. So ms minus half to ms plus half hogta ide anta helidre, difference if you compute difference, it will be 1. So like plus half minus of minus half plus 1 anta bartade, right? So then mi value, there should not be change in mi value. So if you start from plus half, you should go to plus half, that is one transition, and minus half to minus half, that is the second transition. Basically these two selection rules they are followed. ಎರಡು ಕಡೆ ನಿಮಗೆ delta ms is equal to 0 ಅಂತ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. delta ms is equal to 0, it is not the selection rule. So there should be spin state change. Even if you know that basic aspect, you can discard these two options A and D. And ಇವೆ ಎರಡರಲ್ಲಿ ನಿಮಗೆ further you should know that mi value 0 ಇರಬೇಕು ಅನ್ನೋದು ಗೊತ್ತಿರಬೇಕು. Correctly you can answer that. Option B is the answer for this. Simple straight away question this was. The next question, this is interesting question. So because twice or thrice this question has been repeated. As far I remember, once in June 15 similar kind of question had come. Again this question it was repeated in the year December 19, right? So I remember this strongly. Idu question nanu mariyalikke chance illa. Yake anta helindre, so in June 15 I had given examination. Of course I have given my best in this particular test. So like I had all India rank of 44th I suppose, or 33 or 44th, a very decent rank I had in this particular exam. But in this particular exam, similar question or this question itself exactly, this is June 11, and then again it had repeated in June 15 and then again D19. So like I knew about this question, and in June 15 examination when I had given, ಗೊತ್ತಿದ್ದೂನು ಈ ಕ್ವಶನ್ ತಪ್ಪು ಹಾಕಿ ಬಂದಿದ್ದೀನಿ, right? So then I realized my mistake. And when I had again last time when I had given in the December 19 examination, this question it had come, right? So I have repeated my mistake. So I knew that in June 15 I had committed the mistake. Same mistake I have repeated in D19. So therefore I cannot forget this question. Maybe in June 15, if I had got this question, my rank definitely it would have say improved by at least some 10 ranks, I should say. Because like when you go to higher brackets, even 1 and 2 marks, that matters a lot, right? Okay, so keeping that story aside, coming back to the question. So what they say is that the complex, it is tetragonal copper 2 complex. So tetragonal means tetragonal, like Jahn-Teller distortion. If you have studied, you will be knowing what this tetragonal distortion or tetragonal copper complexes are. So like one typical case in the case of copper complex, like two ligands which are in opposite direction, if they are approaching the complex from a little more distance as compared to that of other four ligands. So this can be the most general case of tetragonal copper complex. Of course the other case is also possible. ಏನು ಅಂತ ಹೇಳಿದ್ರೆ ಇವು ಎರಡು ಬಾಂಡ್ಸ್ ಸಣ್ಣದಾಗಿ ಇವು ನಾಲ್ಕು ಬಾಂಡ್ಸ್ ಇಕ್ವಿಟೋರಿಯಲ್ ಅಂತ ಏನು ಕರಿತೀವಿ, ಅದು ಅದರದಲ್ಲಿ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇದ್ರೂ the geometry will be tetragonal itself. But the most common tetragonal geometry that we speak is that two axial bonds, they will be little larger than compared to that of equatorial bonds. This geometry can consider it to be tetragonal, right? So now typically from the EPR perspective, tetragonal geometry bandide anta helidre, it will give rise to axial spectrum. So we have seen three different kinds of spectrum. So like if the environment it is totally cubical, you will get G iso spectrum, right? Isotropic spectrum we get. And if it is this kind of geometry, tetragonal elongation or tetragonal ittu anta helidre, axial spectrum we get, right? And like if all the bond lengths environment it is lower symmetry than this, in that case we can get three different values, gx, gy, gz anta heli 3 value bartade. So that aspect we know. So now coming to this axial complex, or say tetragonal complex, it will give rise to axial spectrum. So axial spectrum means like you will be having two G values, G parallel and G perpendicular ಅಂತ ಹೇಳಿ, two different signals we get with two different G values, right? And in this they have given that, hope you can read this, G perpendicular, this is G parallel, this is G perpendicular, this is GE. So the point that we should notice is that G parallel, it is said to be greater than G perpendicular. Fine. So G parallel ಅಂತ ಹೇಳಿದ್ರೆ it is nothing but GZ. ಯಾಕಂತ ಹೇಳಿದ್ರೆ magnetic field direction always it will be assumed that it will be along Z direction. Magnetic field direction, it will be assumed to be Z direction. So therefore the parallel direction that should be considered as GZ. GZ, it is nothing but G parallel, and G perpendicular, GX or GY, both of them they can be called as G perpendicular. So now point that they have mentioned is that GZ it is more as compared to that of GX and GY. This simply shows that ನಿಮಗೆ G value the interpretation ಹೇಳಬೇಕಾದ್ರೆ ಹೇಳಿದ್ದೆ, higher the G value, it indicates that more electron density in that particular direction. So if GZ it is more, it simply indicates that more electron density in Z direction. So ishtu ಗೊತ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ very easily this question it can be tackled, right? So like copper complex ಅಂತ ಹೇಳಿದ್ರೆ, if I go with crystal field theory, the electron distribution I can write it in this way, E2G6 EG3. So now these EG orbitals we know, dz square as well as dx square minus y square, they are known as EG orbitals. So now according to this observation, what we have concluded is that in Z direction more electron density it should be there. If in Z direction more electron density it should be there, in that case the pair of electrons, for two electrons, they should be present in dz square orbital. See, coming to the question, so they are not asking you where the electron density is more or where the pair of electron is lying, that they have not asked. So what they are asking, where unpaired electron resides, this is the question. So dz dalli ಅಥವಾ z direction dalli ಜಾಸ್ತಿ electron density ಇರಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, in that case dz square it should have pair of electrons. Z square dalli pair of electron ಇದೆ ಅಂದ್ರೆ, it is obvious that unpaired electron it should go to dx square minus y square, and that's how this should be the answer. So why I had committed mistake is that ನಾನು up to this point ಎಲ್ಲದೂ correct conclude ಮಾಡಿದ್ದೆ, but unpaired electron identify ಮಾಡ್ಲಿಕ್ಕೆ ಕೇಳಿದ್ರು. So like I was under the impression that so Z square, Z direction more electron density, and because of that I just went with the dz square, right? So like actually it was dz square which contains pair of electrons, not unpaired electron. So the answer, correct answer for this, it is dx square minus y square. So even if we know that in the copper complex, whatever is the situation, EG orbitals dalli unpaired electron irutte annೋದು ಗೊತ್ತಿದ್ರೆ, these two options they can be readily removed, A and D, because they have given T2G orbitals here, dxy and dxz, T2G orbitals they have given. These two, they cannot be the options. Either it should be option B or it should be C, and careful inspection, it says that option B is the correct answer for this, right? And because of this, further we can say that there will be Z out distortion, and Z out distortion are according to Yon-Teller distortion, or according to Yon-Teller theorem, this degeneracy is to be lost, and the situation it will be like this. All these things are additional, but the point ನಮಗೆ ಬೇಕಾಗಿರೋದು GZ ದಲ್ಲಿ more electron density ಇದೆ, because of which in dz square pair of electrons, if pair of electrons they are residing in Z square, in the other EG orbital, that is dx square minus y square, unpaired electron should be there, and option B, it was the correct answer for this question. Right, the next question, of course, when I had taken the last example yesterday, this was the last example which I had taken for say zero field splitting and Kramer's degeneracy, this example it was taken. So there I had just mentioned this same example, it has been asked, right, in June 2012 examination. So they are asking about the number of fine and hyperfine lines in EPR spectrum. Again ಇಲ್ಲಿ ಮತ್ತೆ ಇದನ್ನ ಆನ್ಸರ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಫೈನ್ ಲೈನ್ ಯಾವುದರಿಂದ ಬಂದಿರುತ್ತೆ, ಹೈಪರ್ ಫೈನ್ ಲೈನ್ಸ್ ಯಾವುದರಿಂದ ಬಂದಿರುತ್ತೆ, ಆ ಇನ್ಫಾರ್ಮೇಶನ್ ಗೊತ್ತಿರಬೇಕಾಗ್ತದೆ. ಸೊ ಫೈನ್ ಲೈನ್, because of zero field splitting, so like only one signal, or say only one yeah, I should say that like though many transitions are possible, one intense signal whichever is expected, so that will resolve into multiple signals because of zero field splitting, that will be called as fine splitting or fine lines. So then whenever it couples with the nuclear spin of the nucleus, whichever is present there, so that we will be calling as hyperfine splitting. So ನಿನ್ನೆ ಇದನ್ನು explain ಮಾಡಿದ್ದೀನಿ. If you take the high spin case of octahedral high spin case of Mn2 complex, 5 unpaired electrons will be there, and 5 unpaired electrons So like they can give rise to 6 different spin states, plus or minus half, plus or minus 3 by 2, plus or minus 5 by 2. And now because more than one unpaired electrons are present and they are present in a ligand environment, zero field splitting is possible. In zero field, these 6 orbitals, they will form 3 set of degenerate orbitals, and each set it will be doubly degenerate. So therefore we can say that Kramer's degeneracy is there. And then when we apply the magnetic field, all these spin states, they will be further split into different energy levels. And exactly in absence of zero field splitting, though just say single line which is expected because of degeneracy of all transitions, because of zero field splitting, so 5 lines, so ಒಂದು ಬರಬೇಕಾದ್ದು 5 ಆಗಿ split ಆಗುತ್ತೆ. So 5 fine lines we can say, right? And based on that itself we can discard some of the options. 5 lines ಬರಬೇಕು, fine lines ಬರಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ 4 and 3 ಇರುವಂತ ಆಪ್ಷನ್ ಅನ್ನು ತೆಗಿಲಿಕ್ಕೆ ಆಗ್ತದೆ. Then further ನಿನ್ನೆನೆ ಹೇಳಿದ್ದೇನೆ ಇದನ್ನ, that say if you consider each line or each transition, then further it will couple with the Mn nucleus. Mn nucleus, it's I value, nuclear spin value, it will be 5 by 2. So therefore if you go with this formula, it says that each line or each transition, it has split itself into 6 different transitions. So 6 into 5, totally 30 hyperfine lines we will get. So 5 fine lines and 30 hyperfine lines. That was option C, which is the correct answer for this question. So this is little tricky question, and it was again multiple select question which was converted to multiple choice kind of question. But options ಇಲ್ಲಿ ನಿಮಗೆ 4 ಆಪ್ಷನ್ಸ್ ಕೊಟ್ಟಿದ್ದಿದ್ರು ಹೇಗಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ like 2 statements, they are exactly reverse of each other. So that's how, if you are very sure about one statement, that statement is correct, the other statement readily you can say that it will be wrong. So the question is about the identification of correct statements for the EPR spectrum of this vanadilyl acetyl acetonato complex. This is the ligand, acetyl acetone ligand, but during the complexation what it does is illinda ಒಂದು proton deprotonate ಆಗುತ್ತೆ and it will function as negatively charged ligand. And so vanadilyl ion VO2 plus ಇರ್ತದೆ, ಎರಡು ಈ ತರದ್ದು ligand ಹೋಯ್ತು ಅಂದ್ರೆ it will form neutral complex of this particular structure. And the geometry, as you can see, it will be square pyramidal geometry. Square pyramidal geometry ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ it should give rise to axial spectrum. So square pyramidal geometry bantu, athwa in technical terms if at all I have to say if it is of C4V kind of symmetry, or even we can say in this case even C2V sometimes ಆ ತರದ್ದು ಬಂತು ಅಂತ ಹೇಳಿದ್ರೆ all those they will result in axial spectrum. Easily you can identify that. The thing is that the environment, it is just one particular way, the environment it is in this plane, whereas the environment it is different in this plane. So therefore axial spectrum barbeku. Axial spectrum barbeku andre earlier also we have seen that 2 G values are possible, that is G parallel and G perpendicular. Fine. So the first statement, it has 2 G values. Yes, correct. Because the structure of the complex, it is square pyramidal, it results in axial spectrum and 2 G values we should get. So if this statement is correct, it has 1 G value, this statement obviously it will be wrong, because these two, they are opposite to each other. If this you are sure that this is correct, obviously this should be wrong. Fine. So therefore what we can do is that C tappiruvantadanna readily you can discard. So here you can find C, here you can find C, these two options. Just even if you know that G parallel, G perpendicular both are possible, then you can be very sure that A should be correct and C should be wrong. So C wrong iruvantadanna ಎರಡು ತೆಗಿಲಿಕ್ಕೆ ಬರ್ತದೆ, right? And A ನಿಮ್ಗೆ ಕರೆಕ್ಟ್ ಅಂತ ಗೊತ್ತಿರೋದ್ರಿಂದ ಈ ಆಪ್ಷನ್ ಆಗ್ಲಿಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. ನಿಮ್ಗೆ ಉಳಿದಿದ್ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬಗ್ಗೆ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೂ just by analyzing the situation properly, it is possible that you can answer, or you can go with A. It has to be correct answer. If A is the correct answer, this D statement it should be correct. It has 2 patterns of 8 lines each. Yes, it is because vanadium, it has the I value of 7 by 2. So G parallel, it will give you one signal, and G perpendicular, it will give you one signal. Both of them, they will undergo hyperfine splitting because of coupling with the nuclear spin of vanadium. And if you want to work out how many lines you will get, so again you can go with this 2ni plus 1 formula. It says that 8 lines you can get, but for both G parallel in the n signal bandirutte, that will also split into 8 lines. G perpendicular in the n line bandirutte, that will also split into 8 lines. So what we can get is 2 pattern of 8 lines. Option D, it is correct statement. A and D is correct statement, that is option A. It is the correct answer for this. So but ಬೇಕಾಗೋದಿಲ್ಲ ಏನಂತ ಹೇಳಿದ್ರೆ, if you are very sure that axial spectrum ಬರುತ್ತೆ, G parallel, G perpendicular ಬರುತ್ತೆ. ಇಷ್ಟೇ ಗೊತ್ತಿದ್ರು careful analysis of the situation, it will tell you that option A itself should be the correct answer for this question. The next question, right, it is a very simple one. So, and we have discussed this in iday tarad complex EPR spectrum in detail. It has been discussed, so therefore it should be easy. Nothing much difficulties I find here. So they say that a complex A on deuteration of NH protons does not alter the EPR spectrum, right? So this fact we know, because nitrogen, it is a NMR active nucleus, or like it is it can involve itself in splitting according to Drago's rule. If that is the case, the hydrogens which are attached to nitrogen, they should not involve themselves in coupling or hyperfine splitting. So that's what they have given, right? Then what they are asking is the number of hyperfine lines in the case of this particular complex ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಇದು ಇನ್ಫಾರ್ಮೇಶನ್ ಅವರೇ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. ಏನಂತ ಹೇಳಿದ್ರೆ ಇದು ಕಪ್ಲಿಂಗ್ ಅಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗೋದಿಲ್ಲ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಈಗ ಯಾವುದು ನಿಮಗೆ ಕಪಲ್ ಆಗುತ್ತೆ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ಕಾಪರ್, yes, unpaired electron it is present on copper, so therefore it has to involve in hyperfine splitting. Oxygen, I value 0, it will not involve. Nitrogen, yes, definitely it can involve, right? So if you had hydrogen here, you should be careful here. If you had hydrogen here, that would have involved in hyperfine splitting, but here they have shown that it is methyl group. So methyl group ide anta helindre these hydrogens involving in coupling, it will be very difficult, because we can say that the unpaired electron will be delocalized over this region, but unpaired electron coming over to methyl group, it is very rare scenario. So therefore these methyl group hydrogens, they will not involve in coupling. So hyperfine coupling, it will be due to copper as well as these two nitrogen. Because of copper, as we know, one line whatever is observed, that has to split into 4. 2 nitrogens, 2Ni plus 1, again we can go with the same formula. It says that it has to split into 5 lines. 5 into 4, totally 20 line spectrum it is expected in this case. That is option A, right? So there are chances that like ನೀವು ಇದೇ ತರದ ಎಕ್ಸಾಂಪಲ್, ಬೇರೆ ಎಕ್ಸಾಂಪಲ್ ರೆಗ್ಯುಲರ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿರ್ತೀರಿ. ಸೊ ಅದರದ್ದು ನಿಮ್ಗೆ ನೆನಪಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅದರ ಬೇಸಸ್ ಮೇಲೆ ನೀವು ಆನ್ಸರ್ ಮಾರ್ಕ್ ಮಾಡಿದ್ರೆ ತಪ್ಪಾಗುತ್ತೆ. ಸೊ ರೆಗ್ಯುಲರ್ಲಿ ವೆನ್ ವಿ ಡಿಸ್ಕಸ್, what we consider is that hydrogen, it will be present here, coupling due to this hydrogen or hyperfine splitting due to this hydrogen, that will also be considered. So awaga number of lines ಜಾಸ್ತಿ ಆಗಿರುತ್ತೆ. ಸೊ ಅದು ಕೊಟ್ಟಿರುವಂತ ಚಾನ್ಸಸ್ ಇದೆ. ಮೇ ಬಿ 60 ಬಂದಿತ್ತು ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. ಐ ಆಮ್ ನಾಟ್ ವೆರಿ ಶೂರ್, but like if you carefully analyze the situation, directly you can say that option A, it was the correct answer for this question, right? So then the last question, this is also easy. The question, it may seem little difficult and little different, but the question, it is actually very easy. So they say that this is R3 germanium twice, right? So if this compound on photolysis, it gives a radical and its EPR, it has been recorded, and the ESR signal carrying the signature of 73 germanium are in terms of germanium. It can have different isotopes. Now they have just given us the information regarding 73 germanium whose I value is 9/2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So ಅದು 73 germanium ಆಗಿತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ what is the hyperfine, or what is the number of hyperfine lines? That is the question, right? So now maybe if you can analyze it in this way, you can understand it quite easily. This is the species germanium dimer, and that has been R3 and germanium twice. Like if I write the structure properly, it will be this. Photolysis, you can expect homolysis fission of this bond, and what you get is 2 this kind of GER3 radicals you get. So now one signal, it is expected due to one unpaired electron whichever is present over germanium. So now number of hyperfine lines, if you want to compute, considering this germanium to be 73, I value it is given 1 germanium nucleus 2 into n and 9/2. Just go for simplification, you will get the answer to be 10, and option B, you can exactly find that 10 lines and put it there. So that is the correct answer for this question.